Anybody has a cap, perhaps? Well, I had the good fortune yesterday of listening to the Dalai Lama, and he was wearing a cap like this and with a visor, and I had a laugh, but he was right.
Fogok beszélni egy keveset arról, hogy azokról az adatokról, ami...
What's the topic of my presentation? How do we raise information out of data, and how can we use our own tools to extract as much information as possible without having to pay a lot? And let me quickly reveal that the syslog runtime log analyzer application is what I'm going to talk about. But due to the shortage of time, syslog ng insider information won't be abandoned. Still, I would just touch upon this by the end of the presentation. I hope you will all begin pondering starting your homemade syslog analysis project. But obviously you will stay here for the night, and on Monday you will start the day with that. Lots of people collect logs, but this is only about collecting them, accumulating them, and archiving them. And you tell people that you have the logs with lots and lots of information, but since you have that heap of information at your disposal, it would make sense to try to extract valuable information out of it, relying on the raw messages that come in. And this is going to benefit us because it's not just a one-off occasion filing the logs away, but you will actually get to know more about events, and I'll give you some tips and hints for queries you can start that any simple system administrator can do. And mind you, I'm a simple system administrator myself. What's the analysis process all about? Certainly we need to gather the messages and then collect information about who's logging what and where. It seems simple, but it varies with the application. And there's lots of different kinds of logs lying about in all kinds of places. So you need to define standard conversion formats because you want a single format to analyze the information, which we call normalization, using a fancy word. And there's two other things that are important about conversion protocol. syslog is the protocol here, and I'm not going to get inside the details. Warn me if I do. And also the format is important because we need a single format, otherwise we won't be able to make sense of that. I heard a database expert once claim that if you have junk in, you're going to have junk out. So you need to be able to make sense of it all, get valuable information, and squelch the noise. If you check your own logs and server logs, you will find lots of clutter inside. I'll show you examples. So then we'll do the analysis, and it will be important that you respond and react. What are the typical pitfalls? First of all, discovering where the logs lie about. syslog, for instance, has many ways of collecting logs. Dev logs and reading files and pipes and streams can all be read, which is important because speaking about a Unix-based system, there's a syslog, and syslog is a good way of keeping log information about the system, and most of Linux users have not heard or not using these, so they would rather use a database or use a network connection or some other solution, and the orange highlight is no message, and that's the key problem. And I think both during yesterday and today there'll be a lot of talking about web-based and, StevieWonder.com sort of website and block content logging issues. And also sundry formats represent a problem as well. Makeshift solutions, well, we have devised our own, and I will show you how it works and how to use it. But that's a problem. And also there are character set mismatches. And these are by and large manageable, but there's also clutter concerns, and that also can be managed. Log entries, messages are sometimes irrelevant. And also using a networked computer, due to the internet economy, there's all kinds of log entries that you would know about anyway. So, for instance, DNS is such that it's normal that every 5 minutes all kinds of weird zones are transferred. It's not even on our own server, it's on the VM server. It's a policy violation. And there's nothing we can do about these. We'd better screen them out, though, because they would just clutter our analysis and potentially distort our conclusions. I'll come back to this. And then normalization. You get raw messages, and you should promulgate them into a common format that can be analyzed, such as timestamps should be converted to the same format, because you have lots of syslog protocols and timestamp formats vary with each. You probably recall last year's presentation, or you may not, because I don't actually myself. And RFC 65, for instance, it has a boot up timestamp, which is not regular because it doesn't have the time zones or fractions of time. And 5424 is already using the ISO timestamp. So it'd be nice to convert them to a common format. And the other thing is using the same data format, because we have 35 applications using 75 different log formats, and unless we convert them all to a single log format, then we will not be able to make any sense of what's in there. And currently the biggest challenge is trying to use a single data format for user IDs and the rest of the data, because that's something that's really hard to address. Now, let's see the format of incoming messages and the key features. There are two parts for most messages: static content, which is the white parts, and variable content, highlighted in orange. In an SSH log, accepted is a variable that varies. It can have two kinds of values, and the password at the moment will depend on the method, for instance, to authenticate the user. And 4 is a static part, and Peter is my user ID, and then a static part, and the IP address, the port, source port, SSH2, and this is the SSH protocol ID. And it can be either 1 or 2. And those of you who have 1 should change to 2. And if you see anything else, you're deep in trouble. And then the next one is an FTP daemon entry. Now you have the ID, the username, and now you are logged in. I'm giving you this example because this one is quite easy to bring to a common basis. And the next one is POP3, a dovcat, an incoming message entry here. We're looking at the same thing, and RIP is the remote ID, LIP a local ID. So this is already merged, and we have a user ID. The IP address is important in this example, and the user ID as well. In the first two cases, for instance, as you can see, the user ID is not between brackets, and in the third case, it is, which is going to be a disturbance during our work. Now, let's check out syslog ng. About 2 years ago, we incorporated a runtime log analysis feature, and that's log Pantan DB. If you've heard of syslog ng, there's an option there, or it rather is compulsory. Log paths and log routines have to be defined, and we have a new feature in the log path. Parcel and rewrite modules can be incorporated. This Panther module can use two different methods to interpret incoming entries, and when we're in luck, I could give you examples of 2 or 3 applications with strictly structured messages. Squid's access log, Apache's access log are 2 such examples, and pure FTP, which I showed you a minute ago, it's one of these. But the problem is many people use other than any of these 3 daemons. They can have up to 15,000 different applications, and we can parse them into columns, and then using CSV we can parcel them up, carve them up to entry paths. But life is not like that. We're generating all kinds of log entries, messages. If you are developers, I'd like to ask you ahead of time, please generate normal format log entries to make life easier. And this parser will be incorporated in the log path, and it will make sense of the log entries. CSV parser will say that this is CSV, and then we will parse the messages, and pack10db is the other parser, or db parser is the other name, and that's radix v pattern matching, which it does for us. And the benefit is that these 2 parsers are going to output recognized values into our own macros, and using those macros we can restructure the messages, or we can separately store them. There's 2 options. First, we can use a template or a rewrite to store them, or you just open up a database and the macro contained information could all be stored in a field of the table and retrieve, and you can use it later on. It's working runtime, and it's a hell of a fast process. And as for incoming messages, we can classify them into all kinds of categories we come up with, such as violation, error, noise, system. And then you can say that each message is part of a category or class, and then you'll be able to do filtering, and you can search amongst the entries. And the other thing, which is not on here, but we can also use tags. We can tag them. All of you read blogs, and blogs have tags attached to them regarding content, and you can assign keywords. So our log entries can also be attached, tags and markers, so that we can mine the sensible information out of them at a later stage. Now let's see how this works. A radix tree is the algorithm we use, and this is a character-based decision tree. So you have a decision tree that's built up. It has one drawback: we can't move back along the tree, because in certain cases we may want to work our way backwards down the tree. Now let's see how the log messages can be further interpreted. Analysts also use regexpat. I wonder if you've written any. These are strings that are easy to get wrong, and a pattern DB is a good solution because these patterns can be put together very easily, looking at the previous message formats. So what we want to do is rewrite the orange parts. And acceptive was not struck, but the authentication user and port information, these were all extracted using a parser. And in between the @ signs, you can expect strings, IP addresses, or digits, numbers. And all we need to do is take the 3, 5, 10, up to 200,000 messages that come in every hour. So we will write the patterns to help analyze them, and then we'll try to apply these values. Now let's check out our parsers. We have a lot more, but some examples are included here. String parsers can be of these kinds: string, E string, and Q string, or any string, and separation characters can also be typified. Q string is a quotation character. In between the brackets, we have the information that I want to read. And there's also a wildcard, any string, which means all the characters till end of line. But you'd better not use it, because it will just mask the information that's in there. Because the looser your pattern, the more likely it will give you irrelevant information, because you can very nicely parse email addresses such as @ sign, and you take the part before and the part after, and you can have dashes, but not another @ sign, because then I could say @ string @ and so on. Instead, I could also check the log entries and say that, we always write the email address and then add a comma. We could use an E string and tell it to use anything until it comes up on a comma or a bracket, because valid email address is open bracket, email address, close bracket.
If there is a decimal point in it, then it's number. If there is not, it's float. So there is no such decimal point in the float. And we have also 3 IP parsers: IPv4, IPv6, and IPv-NY@. What will be the tricky parts? There are some minor things here, but we can answer them one by one. One is the contextual repetition, which I didn't like at the beginning, because I had to pattern in a postfix for myself, for my own purpose. And since I was my own customer in a hobby project, I couldn't quit. And in the case of we use postfix 2 and ORIC 2, which indicates to whom the letter was originally sent by the sender. And here we are expecting an email address, and then what we received, it is not an address. And it was my wife actually who sent the letter, and she put lots of fields into 2, and then I told her to use BCC, and she said that it means something else, as if it is written into 2. And then the problem is that when you expect an email address, then repetitions may occur separated by commas 5, 6, 8. But in that time, a parser must be used, which is already prepared to take them apart. If you just do a simple parser for email address, then it is expecting only one. The other thing is that if there is a single event which will produce a number of commands or reports, and there is nothing, no information in the commands. These log messages very often come without any links. For example, a Windows log generates 3 to 4 log messages, and there is, as far as I could judge, there is no such data that would connect these messages. And also there are messages with missing parts, fractional messages. So we could handle them with default values if it makes sense. For example, in a packet filter, there is no user ID, or there are lots of log messages in which we don't know which user produced it. Packet filter is good for this purpose. We know the IP and the target IP and the client's IP, but we don't know the user's IP. Either from XML or from syslog-ng setting, we can give default values to the database field, and we can handle the default the field with the default value. Let's speak about classification. It's grouping. So we have our messages coming in, and then we can put them or sort them out into message classes. And there are some typical classes such as system violation error warning info. And this is good for us because our internal processes within our company can be connected to one of these classes. A system is normal, is the sign of a normal operation, but violation is something we have to jump to, and the system hosts must investigate what kind of violation happened. For example, we look for the user, we use a stick and hit his fingers. It is fine written in syslog-ng in a macro called .classifier.class, and then later on we can use either in a file name or a database table. The other thing that I mentioned before is tagging, using keywords. I made up some typical text such as noise, login, logout, timeout, human activity, machine activity. It is again a difficult thing to find out if a certain activity was human or machine made. And again, we put it into a macro, dollar tags. We don't have to use any brackets, and all the text will be listed, separated or delineated by commas. Our next task is to put our pattern into an XML file in which we store the messages themselves. There is a version. It should be version 3 instead of version 2. And then we organize the whole thing in rule set. First, filtering is set on the program name, and then it will be in the patterns, and log messages will be put among the patterns. And then we also specify our tags, and here is the class, the specification of class, and specification and setting of tags. This is the XML that we should edit, And if we put a new one there, then the system engine will detect that the new version arrived, and it will just simply read it. Shall we tag or shall we classify? The big difference is that one class may belong to only one message may belong to only one class, but to one message we can assign any number of tags. And for this reason we can do inquiries of all kinds. Let's go back to the previous slides. Remember that we had a system and violation. Successful entry will be login and system, and an unsuccessful entry will be login plus violation, and then we write that it was human activity, and then we can filter for our reports. How do we use them? It has been mentioned several times before that classes and tags can be stored in different places and in different ways, and they can be used in the system engine in different ways. We can use them in SQL fields as the content of the field, or also in the name of tables. If you have a separate table for violations and system messages, then this also can be done. Or we can define filter condition in our log passes and pads, and then we can define file names and path names, where we may have variations, logs, and messages violations. Our next trick, or our next buzzword is was invented by Marcus G. Rano. It is called artificial ignorance, which describes the function as to what happens to messages to which we have no pattern. For this, we assign the class named unknown. And artificial ignorance is the situation when we only read unknown messages and we check only unknown messages, because in every system non-foreseeable events may happen for which there are no patterns, and it is useful to read them. For example, you buy a new server, you install all the patterns within 1 to 3 weeks. It's not a big work, but then afterwards you're happy, and if you don't read the unknown messages, but then in half a year, if either a disk fails or there is something with RAID, then you won't recognize it. But if you have a daily routine of reading unknown class messages, then nothing will go unnoticed, which is the most important thing in reading a log. The most dangerous situation is an abandoned machine, a sole machine. If it's installed and if it's left alone, it will sooner or later fall. We regularly read these unknown messages and then we react to them. We check what they mean, and we modify our database accordingly. We add the new message. A system is good if it runs smoothly and there are no unknown messages. There is another thing as well. What one can do with the content of the message is the essential part, but we are running on time. Those parts that are parsed out, such as the usernames or the authentication method or IP address, can be placed into a macro, and these information can be stored, and then we can react to them appropriately. If you remember, there are these semicolons in the macros, after which we specify also the parameters. For example, a string may accept a hyphen or an underscore or other characters, and also what is parsed out then we may put into this or that variable. For example, log check dot into different log check dot addresses. These are the three log messages that are now combined. They actually came together because we put the IP address into the of my interest into the proper place. How can I react to them? Later on, they will become own macros, and you can name them as you wish. And then but you may use macros to reference them. Dollar, this kind of funny parentheses, and
hogy nincs ilyen, mondjuk egy csomagszűrő log.
And if there is a packet filter situation that we won't have a user ID, but then we can, if the message comes from the same source, then where we specify the default value, like you can see on the default, or in XML, we can set up value pairs with which we can define the given value. And this is the interesting part which is coming up now. How can we analyze it? So if we put the content of a message into a database feed or into a file, we can count them. This is the most primitive analysis. Simple counting. How many such messages, violation, system, noise messages that arrive in an hour. And then we can produce diagrams out of it. But if this number is high on a permanent basis, then with a simple tool that I will show you, can depict them. And a simple counting may be the source for our suspicion. And the other opportunity is correlation analysis. There is only one type of correlation analysis in our case, because we don't have a correlation engine for the time being, but we're working on it. Stored messages will be checked periodically, and we pair those messages that belong together. Let me show you an example with which we can speed it up a bit. But it is not the classical type of correlation which are normally used by log analyzers. For example, I'd like to see the violations according to IPs, or the violations by UIDs, or login events by UIDs, user IDs. How can we implement this? By the go.grep that you know, or by means of SQL view table, which can be very useful in this situation. So all the incoming messages can be logged by the SQL machine. I use different fields to store class tags, IP addresses, and separate fields are used to store user ID. And with a simple view, I generate a table in which only IP addresses and only user IDs are present. And then we can see that what kind of IP addresses were used by a certain type of users to enter. So we can produce statistics like this. I've got to the last slide. Let me just explain to you what you can see here. And of course, this analysis information should be used afterwards. It's not enough to have an SQL table where we just get out information by select, or the system host gets out information. And this is how we can make things visible. There is a special purpose driver which sends to the standard input of login these messages, standard input, and we can also set up a simple reporting script from the selects to see the top 10 violations by users and the top 10 violations by IP addresses. And the third opportunity is the use of Munin and RRD2. If it rings a bell to you, what we can see down here are two diagrams. One is with lots of green is the diagram for the full system. All the information, all the log messages are stored in a tune system by classes. Green is the system, and it's purple are the classes. Green means that normal operation, and the purple part indicates port scanning as an attack. And you can see that in a certain time range, the number of packet filter violation increases. The other thing is the same, but I subtracted the green part of it, the system part of it. And this is the shame on Munin. And we can't tell what value can be generated with what color or in what color. PF violation should not be green here, but should be purple, because in the other diagram green is the color of the system. But here we can see only values of violations and the differences of these values. I didn't really solve it out of laziness to filter out noises. And if there are lots of noises, then certain things can disappear. You can see in the first diagram that there are lots of systems, and on the top of system blocks there are little pixels of other type of information. The vertical field is exponential, but there are lots of system type of messages, and there are just a very low number of non-system messages. So, but they are not properly visible, so that's why I produced the other diagram with the subtraction of the system messages. And one last remark, one last slide. Why do we recommend the use of syslog ng? It really lies in my heart. It is really available on any computer. There are 8,000 accessible patterns, and MySQL, syslog ng, OS, Munin, Bash, and VI were used from any kind of infrastructure elements, and so we didn't have to spend a penny to buy software systems. In the first row, there are colleagues who could tell us stories about the 8,000 accessible patterns we have. For the time being, it's only on they are only Linux logs and some other vendors logs, but these are freely accessible. And there is also one more important thing. We are working on a forming community alongside the patterns, who will help us enthusiastically to collect logs, and then we will start to use our patterns. So if you just go on the Balabit page, then you can pick these samples, these patterns, free of charge. Do you have any questions? Please go ahead and use the microphone if possible, otherwise the interpreters can't hear you. This is the case.
Bejegyzéseket a from, az nagyon sokszor például nem olvasol van.
Igen, ez azért van. Igen, az volt a kérdés, hogy...
The question was if we can converge messages of several lines into one, because many applications do lots of log messages. For example, the postfix in the previous example. If log messages contain several lines, they are problematic, but postfix is extremely good for this purpose. Postfix has lots of small modules, and all these modules do something else. Everything that I've been listing does something else. at least 60 types of different modules like this, and they produce all their log messages of their own. And with postfix, we can order them or assign them to one another, because the first module is the SMPTD that eats up this message, and it generates a message ID for the rest, which will appear in all the other messages, and you will have a field with which you can connect these messages, and you will know that they all belong to one letter. All the log messages belong to one letter, but the queue manager put it into the X queue and into another queue, or the cleanup did something with it, and as SMTP send it forward, or locally you used it locally. Postfix was a good example, because we can pick them into one basket on the basis of this common ID. And let me give you a counter example. If you produce a mail server where you receive logs with postfix and you want to store them with Dovcat locally, because these are your servers, and then you will use the Dovcat for local delivery. Just get it and put it into this or that mailbox, and Dovcat will not destroy this mail ID, and then you cannot order them to form one letter. So here it came in one letter, and locally they are stored there. Here there is no real link between them. But there are lots of applications which produces log lines randomly, and then it will be difficult for you to find out the real time sequence for drawing conclusions. Yes, that's right. That's why I said that this still remains a problem. But as far as I know, junk in, junk out, and there are no people who have solved it yet. Any other questions? If there are no more questions, I'd like to thank you for your attention. And on the other part, I hope that you will start analyzing logs soon. There will be one question, and the price will be one T-shirt. And our speaker will think about a question to put the question to you. For example, let's say you're very pretty. You're looking very pretty in this T-shirt. Can somebody tell me what type of correlation can be implemented with this method? What type of correlation can be implemented with this method? Those who name the most statistical simple correlations will be the winner. So who can list the most will win this T-shirt. And you can put up your hand, give a number. This is one. I would give the T-shirt to him because I really soft-hearted.